Depends on, sometimes.
This is my best size though.
You want to put a little foundation on there for you?
Sure. Okay. The technique that we're doing is called KBr press. Those of you that had me last semester, I do apologize for not showing you how to do this, but you can ask me to catch you up later. This instrument here is called a French press.
Can you flash? The flash.
And what it's going to do is pressurize the samples. In this container here, we have KBr salt. It's high grade. It's called Spectra grade KBr salt. What you don't realize about KBr is that it is water sensitive. It will absorb moisture, so we keep it in an oven to try to keep the moisture off. Okay. Now, to do a solid IR, the first thing you need to do is make sure you don't burn yourself on the hot glass. Is take a little bit of the KBr, you can tell the KBr is wet because there's lumps in it, and when there's lumps it means it's wet, which is bad because that means even though the sample I'm going to run doesn't have an OH signal, we're going to have an OH in our sample. Okay, now it doesn't take very much KBr with our system. Okay, it takes this is probably enough to do 2, and it's hard to take less of this and get it to work. But KBr is very expensive. The last time I had to buy it, it was for 50 grams. It was over $300. So it's very expensive. Okay. Now the first thing I want to do. I don't know if this came from the KBr, if this was already in there. A little brown spot. Got the brown spot out. I'm going to grind it up a little bit because it's a crystal and we want it to be more of a powder. Okay, so you grind it up. And then really I should be making 2 out of this. I should be making a standard and then making the sample, but I'm not going to do that. I'm just going to, it was in here? Where's the other set? There should be 2 sets of these. Okay, well, this is just plain cardboard. We take it to the copy center and they punch a hole in it. That's just they have a big hole punch for doing a lot of paper at once, and so they do a lot of these cards for us. And this is, I just call these metal hockey pucks. I don't know what better to call them. They're stainless steel. They have a polished side and an unpolished side, and we always use the polished side. You put the card on that, and then you prepare your sample. Now, it doesn't take much sample. Those of you that are in forestry, you may not know how much this is. Yeah, this is just while we take 10 milligrams of sample, and then you took a melting point, so this is whatever's left over. I don't need much of this. You have to watch out for my big butt. Okay, it takes just, I'm letting them take a picture first and then I'll walk it around. Just takes this much sample. Okay, and this is actually probably more than I need. Can you see it over there for me? Okay, then you put this in with the salt. I actually, when I teach this in my 420 class, I usually say you just take your spatula and wave it over the sample and put it in. The biggest mistake students make is they add too much of this solid organic material to the salt, and it causes their windows to become occluded. And now I'm going to mix the salt and the sample and then continue grinding it while it's mixing. And then when I'm happy with it, I now take the salt and scrape it towards the front. I guess I should show it so that the cameras can do. Okay, and now what we're going to do is we're going to make a little mountain over the hole in that card. I usually just say make Mount Vesuvius or Mount Fuji or Mount St. Helens or whatever volcano you want. And you want a fair amount of it. Let's put a little bit more on there. Okay, so if you guys want to take a look at how much I put on, just come by and take a look. 420 people really should.
Sorry.
Okay? And then you put the other metal cylinder on top and slide it onto the French press. And now we're going to put it under pressure. You start off gentle so that you don't jiggle it too much until you've got some pressure on it. And there's a dial on this French press over here. You want it, there used to be a wedge of tape there, and you wanted to get the needle to the edge or just inside that tape. It should be somewhere between 6,000 and 8,000 psi. Okay? Now, what happens when you put it under pressure? When you put sodium chloride under pressure like this? It turns into a liquid. Okay, now, I'm not sure whether or not the organic material turns into a liquid or not, but in any case, it will now disperse throughout the salt. And so you should get a dispersion of the organic material inside the salt. It doesn't have to be under pressure for very long. And you release the pressure, and as soon as you release the pressure, the salt re-solidifies. And if I did this right, my fingers and hands are just too big for this, unfortunately. You get a clear window. Ladies, you.
Thank you.
Okay, so you see it's a clear window.
I'm recording.
We can this available to you.
Yeah, there's a couple of cracks in this. That doesn't matter. Okay, now, the IR is right here. And so, this is the IR itself, and it's attached to this computer. One of your students' flash drive. Is that yours? Okay. Can I just collapse this? Okay. Program. This is actually, do you teach 223B? This is the anhydride product.
I should look right here.
Okay, so we run the IR through this computer. We'll just put this in. Well, before I put it in, I forgot I just turned it on. I have to take a background. And you have to take a background because there's stuff in the air that absorbs infrared light. There's one component that's particularly bad, it's carbon dioxide. Carbon dioxide is, of course, a common component of the air. In fact, as we're standing here, the concentration of carbon dioxide in this room is going higher and higher. Okay, so we're going to have a carbon dioxide signal, amongst other signals. But if you want to come over here and take a quick look, I'll show you where the carbon dioxide signal is. This peak right, this double peak right here. That's carbon dioxide. Carbon dioxide has a symmetrical and asymmetrical stretch that appear at approximately the same position. Okay. What's nice is that there's nothing else in organic chemistry that shows up in the same place that carbon dioxide does. And you probably wonder why you never see carbon dioxide in the IRs that they give you for exams and stuff. That's because those have been doctored to remove the carbon dioxide signal. Okay, sometimes they're literally just whited out and somebody's carefully drawn a line across that region just so that you don't have to see it. Doesn't confuse things. But they're always there to some extent. I'm going to say no to this, and then I'm going to run the sample. I'm going to take a picture of that before I start running. Here.
Okay.
Yeah.
Now this instrument runs 16 scans and averages it. That's how we have it set up. So in that little bit of time I said I was collecting a background, it ran 16 scans. It's that fast. And it ran 16 scans over reciprocal wavelengths of 400 to 4,000 reciprocal centimeters. So it's doing a lot of work very fast. Okay, now I'm going to collect the sample. And now it's collecting. And so here, one of the things that when I teach the 420, my 420 students to do this, I tell them they know what compound they're making. So when they look at the IR, they know what function groups are in that compound. They should know where to look at. Okay, so the 420 people that might be here, I don't see any of them left maybe. Oh, there's Daniel back there. This compound has an alkene and it has an anhydride. Okay? So we're looking for those two functional groups. Say yes to this. Now, if you come take a look at it, here is our spectrum. We have a problem here in that the carbon dioxide peak is really ruining this. Because it's going up, and that surprises me. Because the more people that are here, the more carbon dioxide there is in the room, which means it should keep absorbing more and more each time. But you guys must have stopped breathing between me running the control and me running this, because the carbon dioxide level in the air actually decreased during that time. Okay, so I'm going to take that out. Because it's messing up. There we go. Nope. I'm just expanding this spectrum. There we go. And I'm going to emit the carbon dioxide signal. Okay? So this is our spectrum. And it's an anhydride, so it should have, what should be the signal that we're most interested in seeing? We should be seeing carbonyls. There are two carbonyls, but they're identical. So they'll probably show up the same position. And that's what we have here. This signal right here is our carbonyl. Now we also see there's an OH peak, and that's what I told you. The salt itself is wet. if I was to do this and going to publish it, I would treat the salt completely different. I would make sure that it didn't have any water on it when I ran this. But we don't have time to do all the special treatments for it, so we just say, okay, there's water in it that came from the salt, moisture from the salt. Okay, but this is the spectrum, and it's actually quite a good spectrum. Okay, so now what you have to do is you have to show where the peaks are. And the easiest way to do that is go to Analyze and find peaks. And it gives you this. So now it's found all the peaks, replace, view, full, take out that carbon dioxide signal again, and there, that's our spectrum. It's not as good as it could be, but it's good enough to use. Okay, so I'm going to go ahead and print this out. Print. Print. And so it'll print out here, and now we have a copy of that in case we need to analyze it for our report. Okay? And so that's what it looks like. Okay, so when I tell you what discussion points to cover and what questions, I'll tell you at the same time whether or not I loaded this up on Beachboard for you so that you can also use it if necessary. Okay? Any questions on that? All right, so really taking a solid IR is not that bad. It's just where the students make the biggest mistakes are they don't use enough salt over the little hole, and they use too much sample. And that's the biggest mistakes that the students typically make. Okay? If there's no questions, you guys go ahead and clean up. And I'll clean up in here and I'll be in within a few minutes.
I'm good to go.